If you took a DNA test and it said you were 50% Eastern European and 50% Middle Eastern, most people would assume your family came from two completely different worlds. But for millions of Jewish people, that result describes a single, unified ancestry, and ancient DNA just revealed exactly how that happened. Genetic testing companies today can separate Ashkenazi and Sephardic Jewish ancestry with over 99% accuracy, an astonishing figure for two groups that share deep roots in the ancient Near East. On a principal component analysis plot, which maps genetic similarity across populations, Ashkenazi and Sephardic Jews fall into distinct clusters. The gap between them is so wide that it rivals the distance measured between entire continents. For many, this finding feels counterintuitive. Both communities pray in Hebrew, follow the same religious calendar, and trace their origins to the biblical Israelites. Yet at the molecular level, their genomes tell two sharply different stories. This split is not subtle. Modern DNA classifiers, trained on thousands of samples, can assign an individual to either Ashkenazi or Sephardic ancestry with near-perfect precision. The algorithms that power consumer DNA tests use hundreds of thousands of genetic markers, but even a compact set of SNPs, just a few hundred, can distinguish the two groups as reliably as they can separate a Spaniard from a Pole. The separation is so consistent that it forms the backbone of ancestry reports and medical screening panels worldwide. What could have driven such a clear genetic divide within a single people? The answer is not hidden in myth or distant memory, but in the measurable patterns of shared DNA segments, the echoes of migration, marriage, and survival. These patterns set up the central question: how did two populations, both descended from the ancient Levant, become so genetically distinct that a computer can tell them apart with the certainty of a border guard checking passports? In the heart of medieval Germany, beneath the soil of Erfurt, a Jewish cemetery preserved a record of one of the most dramatic contractions in Jewish population history. Genome-wide data from 33 individuals, dated to just before the 1349 pogrom, reveal a story written in long, uninterrupted stretches of DNA, called runs of homozygosity, that speak to a severe founder event. Modeling these genetic patterns points to a population bottleneck around the turn of the first millennium, when the effective number of Ashkenazi ancestors shrank to only about 300 to 400 people. This contraction was not gradual. The evidence suggests a sharp reduction, likely driven by migration, persecution, and enforced isolation as Jewish families settled along the Rhineland. The consequences of this bottleneck are visible at the molecular level. The Erfurt genomes show more internal diversity than modern Ashkenazi Jews, but they already carry the extended homozygosity and pathogenic variants that define the group today. Disease-causing mutations, like those responsible for Tay-Sachs and Gaucher disease, are present in these medieval remains, showing that the genetic risks familiar in modern Ashkenazi communities were seeded centuries earlier. The founder event amplified these rare alleles, locking them into the population through generations of endogamy and demographic isolation. This is not a story of genetic purity or exclusion, but of survival under pressure. The Erfurt Cemetery stands as an empirical witness, a small medieval community, shaped by history and circumstance, left a signature so distinct that it endures in the DNA of millions today. In 1492, the Alhambra decree forced nearly 200,000 Jews to leave Spain, scattering families who had lived in Iberia for centuries. The sudden expulsion was not just a rupture in daily life. It set in motion a new kind of population history, one shaped by the movement of entire communities across the Mediterranean. Ottoman port cities like Thessaloniki, Istanbul, and Izmir became magnets for the displaced. Contemporary Ottoman tax records and synagogue registries document the arrival of these refugees who established thriving congregations almost overnight. The newcomers brought with them not only their language and customs, but also a commitment to maintaining communal cohesion. Marriage contracts and community bylaws from the 16th and 17th centuries show that Sephardic Jews practiced endogamy, but with a pragmatic openness to their new surroundings. Genealogical and genetic studies now estimate that, despite centuries spent in cosmopolitan cities, Non-Jewish admixture in most Sephardic communities rarely exceeded 5%. The genetic record reflects this balance. A dominant Levantine core, layered with modest traces of Southern European, Balkan, and North African ancestry, depending on the port of resettlement. Through communal institutions, synagogues, schools, and burial societies, Sephardic Jews preserved a strong sense of identity while adapting to new realities. Their genetic distinctiveness today is not a measure of purity, but a record of resilience and adaptation in the face of exile and dispersal. The year 70 CE stands as a turning point in Jewish history. Roman legions stormed Jerusalem, destroyed the Second Temple, and shattered the political and religious center of Judea. In the aftermath, tens of thousands of Judeans were forced into exile. Ancient sources and modern scholarship agree that many were sent by ship to Italy, some as slaves, others as refugees, forming new communities along the trade routes of the Mediterranean. These early migrants carried with them the genetic legacy of the Southern Levant, a core ancestry that would persist for millennia. Yet, exile did not mean isolation. As Jewish families settled in Roman Italy, southern France, and North Africa, they encountered new neighbors, new customs, and new genetic influences. Historical records from the Roman period describe waves of conversion to Judaism, particularly in urban centers like Rome and Ostia. Population genetic modeling, drawing on both ancient and modern DNA, detects a pulse of Southern European ancestry entering Jewish communities during this era. The signal is clearest in the genomes of later Ashkenazi and Sephardic Jews, who both retain a substantial Levantine core, but also carry markers that cluster with Italians and other Mediterranean populations. This early admixture did not erase communal boundaries. Archaeological and textual evidence shows that Jewish communities in the Western Mediterranean maintained distinct burial practices, dietary laws, and religious leadership, even as they adapted to local environments. Over generations, these communities became way stations, places where Levantine traditions met Southern European genes. The genetic record, layered and complex, reflects this history of movement and adaptation. By the time Jewish populations began their divergent journeys north into the Rhineland and west into Iberia, the groundwork for later genetic differences had already been laid. The diaspora set the stage not only for survival, but for the parallel histories that would define Sephardic and Ashkenazi Jews in the centuries to come. The search for a common origin leads deeper into the archaeological record, to the Bronze Age fields and settlements of the southern Levant. In 2022, a research consortium published a landmark study in Cell, assembling genome-wide data from hundreds of ancient individuals excavated across Israel, Jordan, and Lebanon. These remains, dating from 2500 to 1000 BCE, offered the first direct window into the populations that gave rise to later Jewish communities. The researchers applied QPADM and dates methods, statistical tools that estimate ancestry proportions and the timing of admixture events. Their results were striking. Both Ashkenazi and Sephardic Jews today inherit between 40 and 60% of their genomes from these Bronze Age Levantine ancestors. This core ancestry is not a faint echo, but a robust signal, persisting through thousands of years and across continents. The ancient genomes themselves reveal a people already shaped by earlier migrations, carrying a blend of local Neolithic DNA and genetic threads from the Zagros Mountains and the Caucasus. Yet, it is this Levantine core that endures, a molecular signature that unites Jewish populations despite centuries of separation and upheaval. The scale of the data set, hundreds of individuals spanning 5 major archaeological sites, allowed the team to trace genetic continuity across millennia. The findings were not limited to one community or region. The same Levantine signal appears in both Ashkenazi Jews of Eastern Europe and Sephardic Jews of the Mediterranean. This is the genetic bedrock, a shared foundation that predates the Roman diaspora, medieval bottlenecks, and all later admixture. In the language of DNA, the ancient southern Levant remains the ancestral homeland, inscribed in the genomes of millions today. The differences that would later arise, through migration, isolation, or adaptation, are layered atop this Bronze Age core, not in place of it. This shared origin, now mapped at the molecular level, sets the stage for understanding how two peoples could diverge so sharply while carrying the same ancient inheritance. Today, ancient DNA does not define who is Jewish. It documents how two communities, shaped by exile and adaptation, preserved a shared lineage through divergent journeys. These genetic signatures are survival stories written in code, not proofs of authenticity. In a world divided by difference, that distinction matters more than ever.